In today's lecture, we will learn the main concepts of homogeneous differential equations. We will also see what are the equations which are convertible to homogeneous, and then we will solve some problems on that, and if time permits, we will do some exact forms. Okay. So, in the last lecture, we were learning what exactly is a homogeneous expression. We have learned a definition for that. We have also seen some examples for homogeneous expression, and then we went on to define homogeneous differential equation. So, here whatever is the expression in the RHS, that expression must be homogeneous expression of degree of homogeneity 0. Only then we call the equation as homogeneous equation in differential terms. Now, also we have understood the method last time. What is the method? We have to put y by x as a new variable t or z depending on your convenience, and then when we substitute this, the entire equation will get converted into variable separable form. Okay. So, after that you can solve the question. So, now let us look at a problem based on this idea, and through solving this you will also learn the method of solving it. Okay. And also you will understand the logic behind the method. Okay. So, here what is our first step? We have to form y dash and we have to form a function which is of x and y. So, y dash means it is dy by dx. So, here there is one dx, there is one dy. So, to convert this into dy by dx, we have to divide with dx, and then we have to divide with 2xy also, to make sure that dy by dx remains on one side. Okay. So, what do we get here? We get y dash is equal to minus x square minus y square divided by 2xy. Okay. So, now how do we proceed further? We have to divide with x square. So, when we divide with x square here, what do we get? We get minus 1 plus y by x whole square divided by 2 into y by x. Okay. What is our next step? Put y equal to some zx. This means we have taken y by x as z. Now, when we differentiate this, we will get y dash equal to z dash into x plus z into 1. Basically, we have applied the product rule of differentiation. We have to substitute it in place of y dash. So, what do we get here? Z dash into x plus z is equal to, in the RHS, in place of y by x we are putting z. So, it becomes minus 1 plus z square divided by 2z. Now, you have to send this z to the other side. This is always a standard step. Okay. So, in every question after this stage of substitution, we have to send z to the other side and then simplify it. It is very regular process. So, what do we get here when we subtract it? So, minus 1 plus z square by 2z minus z, this is going to give us minus 1 plus z square minus 2z square divided by 2z. So, this will be minus 1 minus z square by 2z. So, we will write this as dz by dx, which is the z dash into x is equal to minus common 1 plus z square by 2z. Now, what is the next step? To separate the variables. So, when we take all terms of z to this side and all terms of x to the other side, what do we get? 2z into dz by 1 plus z square is equal to minus dx by x. So, we have separated the variables here. So, what is the next step? To integrate this. So, we can write 2z by 1 plus z square into dz, and instead of keeping this in the RHS, I will take it to the LHS also, it does not matter. So, dx by x, this must be equal to 0, and now we are integrating this. If you look at this term, it is actually the easiest term. If you observe, Derivative of 1 plus z square is same as 2z. So, numerator is the derivative of the denominator. So, this looks like integral of f dash divided by f. What is the integral of that? Ln of f. So, we can straight away write that it is ln of 1 plus z square plus here we will get ln of x, and there must be one integrating constant which we can take it as a constant k, or we can also write it as log of constant c. I have taken this log because there is log in the LHS also. Okay. So, now what is the next step? Next step is to simplify this. So, log of 1 plus z square into x, this must be equal to log of c. So, because both sides are log, we can equate the index. So, we can say that 1 plus z square into x is same as c, or we can also substitute z as y by x here. So, 1 plus y by x whole square into x will be equal to c. So, when we simplify this, we will get x square plus y square by x is equal to c, or in other words, we can write it as x square plus y square minus cx equal to 0. So, this will give us one family of circles. Okay. So, here if you understand the overall process, the process is very simple. The moment we use this substitution, the differential equation will get automatically simplified and it gets converted into variable separable form, and after that it is the same process again and again. Okay. So, that is it, that is the method of homogeneous differential equations. Okay, come on, make a note of this. Okay, this page also. Now, let us look at a special case of this homogeneous differential equation. So, now if you look at this equation, this is one typical example of convertible to homogeneous even though it is not in homogeneous form. So, here we only take linear by linear examples. Okay. Now, coming to the general discussion on this, if you notice the earlier problem, it is actually very lengthy problem, because converting into new variable and then simplification, this process itself is actually tough. And if you also observe in this method, in the RHS, we always get dx by x. We always get this term dx by x with plus sign or minus sign, and term in the LHS keeps on changing. And most of the times the differential equation that we will be getting will be tough to solve because of the LHS. So, integrating LHS may take longer time sometimes. So, in mains level, we generally do not get questions on homogeneous forms. So, it is very rare in mains, and in advanced we may get questions from homogeneous form, but convertible to homogeneous is even further rarest of the rare. Okay, because this is even longer than the earlier one, because first we have to convert this into homogeneous form, and then after converting we have to again solve it. So, it takes even longer time. So, that is why these type of lengthy questions do not come in advanced also. Okay. But let me explain the method here. Now, the problem with this form is basically this C1 and C2, that is actually the problem. So, let us discuss this qualitatively once. Suppose here if C1 is equal to C2 is equal to 0. If C1 and C2 both become zeros, then basically we are dealing with homogeneous form. Okay. This implies differential equation is homogeneous. Okay, it is homogeneous. But when it is not 0, when C1 and C2 are not exactly 0, okay, If C1 is not equal to C2, definitely they are not equal to 0. So, I will put it like this, I will put a comma here. So, when they are not 0, our right hand side is not a homogeneous expression. Then what to do? Then we will get two different cases. One case is A1 by A2 is equal to B1 by B2, and the other case is A1 by A2 is not equal to B1 by B2. So, when A1 by A2 is not equal to B1 by B2, we will discuss the conversion of the equation into homogeneous form. But what happens when it is equal? Then it is again an easy question. Okay. So, this is the conversion technique. So, this we have to learn. Conversion technique. But this is actually easy. We will see one such case here. Okay. So, if you take this page, here that is exactly what we have discussed. Suppose let us say A1 by A2 is equal to B1 by B2. That means, if you look at these two terms, only the x and y terms, these two will be proportional. Okay. We can write the above expression, this part only, as a factor of this. So, that means k into this expression equal to the denominator. So, that means we can divide it by adding and subtracting appropriate constant, and then by assuming this to be t or by assuming the entire denominator to be t, we can solve it directly using variable separable method. Okay. So, when this condition is valid, when this condition is applied, then again differential equation becomes very simple differential equation. Okay. So, that will basically converted into this kind of form, y dash equal to f of ax plus by plus c, that will converted into this form, and this form can be handled by directly assuming ax plus by equal to t or ax plus by plus c is equal to t. Either of these substitutions will work here. Okay. So, this is an easy case. So, we are not taking examples on this. If you are interested, you can try this example. Y dash equal to, let us say, x plus y plus 2, and in the denominator we have x plus y plus 1. Okay. So, try doing this, you will see how easy it is. Okay. Now, let us look at the other case, which is this case. So, when they are not equal, how to convert? So, for this the idea is very simple. We substitute small x equal to capital X plus h and small y equal to capital Y plus k. Okay. So, here what is our differential equation? It is y dash equal to a1x plus b1y plus, see this is the differential equation here, this one. So, in place of x, where I will put capital X plus h, in place of y I will put capital Y plus h, then it will look somewhat like this. Okay. So, when I substitute this for x and this for y, what do I get? I will get a term like this. So, that means if I separate the variables, these are the variables and this will become the constant, because h and k are basically the constants. Okay. Similarly, here also this part will become the variable term, this part will become the constant term. Now, let us look at the original idea. What was the idea? If C1 and C2 were 0, then differential equation was homogeneous, right? Now, by substituting plus h and plus k here, I got a new constant, and somehow if I can make these two constants zeros, then the equation will become the homogeneous. So, what I will do is, I will put these two equal to 0 and I will solve those two equations to get the values of h and k. So, that means I am forcing the terms to be 0. Okay. So, I am actually forcing this to be 0 and I am also forcing this to be 0. So, when I enforce it, I will get two values, one for h and one for k, which also means by choosing those appropriate values of h and k, we can make sure that these two terms are zeros. Now, once if these two terms are zeros, then equation will naturally become the homogeneous type. Then we will solve it using the regular method. Okay. So, this is the overall approach of the entire method. Okay. So, now let us look at this using one illustration. So, in this illustration, I am going to explain how to convert this into homogeneous form. Only till there I will explain, but I will not solve it completely. So, here the illustration, the purpose of the illustration is only to show you how to convert this equation into homogeneous form. Okay. So, let us do it. So, in place of small x, I am substituting capital X plus h. In place of small y, I am substituting capital Y plus k. Okay. So, there is one more thing here which I have not explained earlier, which may be a confusion to you. So, again I will try to explain this. So, from here if I take d of small x, what is the meaning of this? It is a differential of x, which means it is a minute change in x. Now, looking at the RHS, h is a constant, k is also a constant. So, when I apply the differential in capital X, it will basically become d of capital X and d of h will be 0. There is no change in h. So, d of h is 0. Okay. Similarly, here differential of small y is same as differential of capital Y, which also could mean that dy by dx is nothing but dy by dx. In the LHS we have small letters, in the RHS we have capital letters. Okay. Now, this is one basic conceptual understanding. Now, let us go there. Okay. So, what we are basically substituting here is in the RHS, in place of x we are putting x plus h and in place of y we are putting y plus k minus 7 here divided by here 2 into capital X plus h plus 3 into capital Y plus k minus 6. Okay. Now, what is our next step? To simplify this, so I will take only variables to one side and take all the constant terms to the other. So, here it becomes 6h minus 2k minus 7 divided by 2x plus 3y plus 2h plus 3k minus 6. Okay. Now, as again we have mentioned, this constant term is the trouble. Okay. So, we will make sure that we trouble the trouble. Okay. So, we make sure that this trouble is eliminated by equating these two terms to 0. So, now when I equate these two to 0 and solve them like linear equations, I will get a solution of h and k. Okay. So, let us say I solve these two, 6h minus 2k minus 7 equal to 0, 2h plus 3k minus 6 equal to 0. Okay. So, how do we solve it? H here, k here, 1 here. Basically, I am using the cross multiplication method or Cramer's rule. So, minus 2 comes here, 3 comes here, minus 7, minus 6, 6 here, 2 here and minus 2, 3 here. You know this method. So, what do we get? H by 12 minus 21 minus 21. So, 12 plus 21 it becomes 33 is equal to k by minus 14 and plus 36 it becomes 22 is equal to 1 by 6 into 3 is 18, 18 minus minus 4, 18 plus 4 it becomes 22, which means h equal to 3 by 2, okay, and k is equal to 1. So, that means by choosing these two values for h and k, I have made sure that this expression has become one homogeneous expression. Okay. So which means our entire differential equation will look like this. dy by dx is equal to 6x minus 2y divided by 2x plus 3y. Okay, so this y must be the small y, capital Y. Okay. So now it is homogeneous, you can handle it on your own. Now what exactly has happened here? Let us look at this entire analysis geometrically. So when we looked at this kind of differential equation, we had one linear expression in the numerator, one linear expression in the denominator. Now when we are actually taking two linear expressions, let us say by a choice or by something, if you shift the origin to some other point, what happens? In place of x, x plus h comes, in place of y, y plus k comes, right? So basically you can imagine that by applying this transformation, basically what we are doing is we are shifting the origin. We are shifting the origin to a point h comma k. When we shifted the origin to the point h comma k, what happened was this numerator, this became one line passing through the origin. This also became one line passing through the origin. That is how we got the homogeneous expression. Okay. So that is the main idea of this entire process. So this entire process may look algebraically confusing, but geometrically it is very simple. We have basically shifted the origin and got a new differential equation. Okay. So that is the whole idea. So when we solve this differential equation, this one, we may get one solution. We may get one solution. So that could be general solution or particular, but we get one solution. So after we get the solution, we have to go for the reverse substitution using these values of h and k. So that means the solution will be a family of curves having centered at the origin. Maybe there will be center or there is no center, but reference point is the origin. And then we may have to shift it back to get the original solution. Okay. But whatever is the solution that we get here, let us say we get family of circles, then family will not change. It is of course the same family even after shifting also. Okay. So that is the whole idea of this theory, and I hope you have understood this both algebraically and also geometrically. Okay. Come on, make a note of this. Okay. So can we move on to next page? Okay. So now let us take up some questions and solve them using this technique of solving differential equations in homogeneous form. Now I will try to solve all questions till the answer. Okay. So let us take this question. This is the pure homogeneous differential equation. So what is our step? To divide with x square and take y by x as a new variable. Okay. Okay. So here it is y dash is equal to y by x whole square minus 2 into y by x minus 1 divided by y by x whole square plus 2 into y by x minus 1. Okay. And we are taking basically y by x as one new variable, let us say z, okay, which also means z equal to y equal to zx. Then y dash becomes z dash into x plus z. Okay. So LHS becomes z dash into x plus z. And what about RHS? RHS will become z square minus 2z minus 1 by z square plus 2z minus 1. Okay. Now what is our next step? Take the z to the other side. As I told, these steps are common in all questions. So z dash into x is equal to z square minus 2z minus 1 by z square plus 2z minus 1 minus z. Now we have to simplify it. Okay, so what do we get? z square minus 2z minus 1 minus z cube minus 2z square plus z divided by z square plus 2z minus 1. Now, there is z cube in the denominator, numerator, so problem got complicated naturally. Okay. So, that is exactly why this method is a little lengthy method. So, let me just simplify that RHS here. So, after this we are doing it here. So, z dash into x is equal to, there is one z cube, so minus z cube, and there is one minus z square. Okay, there is one minus z and there is minus 1 divided by z square plus 2z minus 1. Okay, so now there is something that I notice here. Even though numerator is having degree 3, it is actually easily factorizable. If you notice, z plus 1 is a common factor in this. So, if I take z plus 1 common, we can write it as minus into z plus 1 into z square plus 1. These are the factors of the numerator. Okay. So, this is our sheer luck. Okay. So, luckily it got simplified. Now, we know that z dash is basically dz by dx and there is into x here. So, what is our target? To go for the variable separable. So, let me take all terms of z to LHS and all terms of x to RHS. So, what do we get? Z square plus 2z minus 1 by z plus 1 into z square plus 1 into dz, and there is one minus sign involved, I will keep that with x. So, here we will get dx by x. So, as I told in the earlier question also, our RHS is always going to be dx by x, which is simple form. So, here main hard work is on the LHS. So, in earlier linear differential equation, if you remember, main hard work is on the RHS, but here main hard work is on the LHS. Okay. So, then we have to somehow integrate this, but because we already got some factors in the denominator, we will try to convert the numerator also in terms of these factors only. So, how do we do it? By using this manipulation. I am going to add z square here and I will subtract one z square here. So, then what do I get? I will just simplify LHS. So, we will get 2z square plus 2z minus 1 plus z square common divided by z plus 1 into z square plus 1 into dz, right. So, here I notice that if I take 2z common, I am also getting z plus 1 here. So, 2z into z plus 1 minus 1 plus z square divided by 1 plus z into 1 plus z square. Now, see if there are any terms which are actually getting cancelled here. When I divide the first term, z plus 1 will get cancelled. So, we will get 2z by 1 plus z square, and when I divide the second term, 1 plus z square will get cancelled. So, I will get minus 1 by 1 plus z. So, this is one kind of simplification which actually gave us two simple terms which are easily integrable, but every time we do not get easy forms like this. Okay. It is just some pure sweet accident. Okay. So, now how do we proceed with the integration? So, let me write these steps. So, we are going to get integral of 2z dz by 1 plus z square, this is the first term, minus integral of dz by 1 plus z, and in the RHS we have minus dx by x. If I put it in the LHS, it becomes dx by x and RHS is 0. Now, we want to integrate it. The first term is now very simple term because 2z is the derivative of 1 plus z square. So, we can write it as log of 1 plus z square minus here again we will get log of 1 plus z, and here we will get log of x, and RHS will have integrating constant which is k, or we can also write it as log of c. Okay. So further, what is the idea? There are 3 logarithms here. If there is minus, we divide in the logarithms. If there is plus, we multiply them. You know the properties of logarithms. So we can basically write it as log of 1 plus z square by 1 plus z into x equal to log of c. So we can directly equate the indices now. But before we go for that step, I am also putting y by x at the same time. So basically I am using 2 steps together just to save time, okay. Because now here that I am explaining to the students, that is why I am writing so many steps. Otherwise, if my solving process is good, generally my mind will predict the next steps when I am writing the first step. So that way we can actually skip 1 or 2 steps and move on to the next stage. That way we can save time also, okay. So here when I put y by x here, what do I get? I get x square plus y square by x square, right? This is the numerator. And when I put y by x here, I will get x plus y by x. This is the denominator. There is one x here, okay. So this x is in the numerator, okay. So x here, and there is c here. Now if you notice, one x will get cancelled with this and other x will get cancelled with this. So we will basically get x square plus y square is equal to c into x plus y. This also becomes family of circles, okay. So here if you notice, this substitution process may look simple, but it is actually very long process. So even if you notice here, first we do the substitution, then subtraction of z, this process is long, then we have to take it to the other side and then try if we can integrate it in simple terms. If not, we have to go for the techniques of integration. So it takes longer time. That is why homogeneous method is generally lengthy method, okay. So this is one example that with which you can observe every step that we have discussed till now, okay. Come on, make a note of this. This page also. Okay. Now let us solve another question. Now this is a little twisted and different question. So here also we have to keep y dash in one side and everything else in the other side and simplify it and see if it is homogeneous or not, okay. So what is our step? We have already dy by dx here, we take it as y dash. So it looks like x into y dash minus y is equal to x divided by tan inverse of y by x. Now we take y to the other side and divide with x. So it becomes x into y dash equal to y plus x by tan inverse y by x. If I divide with x, it becomes y dash equal to y by x plus 1 by tan inverse of y by x. Now look at this and tell me if this is homogeneous or not. The first term is not having any trouble. It is very simple term, linear by linear both are homogeneous, so hence it is homogeneous. But the next term is actually confusing because it is not of the type polynomial by polynomial. But still it is also homogeneous because whenever there are the variable terms, wherever there are the variable terms, there the expression is the homogeneous. So hence this is also a homogeneous expression. Remember, every time homogeneous expressions do not come as polynomial by polynomial. Sometimes within a function you could face one polynomial by polynomial also. This could be sine also, sine of y by x or cos of y by x or e raised to y by x, log of y by x. All these are feasible terms only, all these will naturally give you homogeneous expressions. So this is also a homogeneous differential equation, okay. So now what is the method? Method is simple. we take y equal to xz, which gives us y dash as z dash into x plus z, right? So it becomes z dash into x plus z, and what is RHS? This part will become z and this will become 1 by tan inverse of z. Okay. Now luckily this z got cancelled, and then we can separate this using variable separable and solve it. Okay. So what do we get? We have dz by dx here. So dz, and this when it comes to the LHS, it becomes into tan inverse z, and RHS becomes dx by x. So as I told, always RHS is dx by x. Okay. Now we want to integrate this both sides. So how do we integrate the LHS? By using integration by parts. You know that we will integrate 1 here and differentiate the tan inverse. Okay. So it becomes somewhat like this: z into tan inverse z minus integral of z into 1 by 1 plus z square into dz, and in the RHS, integral of dx by x is ln x plus some constant. So I'll take it as ln c there. Okay. But we generally don't put constant till we get the final answer. Okay. But I have just put it there. Okay. So what do we get here? Z into tan inverse z minus, here derivative of 1 plus z square is 2z. I think in this is the third time we are using that form in today's lecture. Okay. So it becomes 1 by 2 into log of 1 plus z square. This must be equal to log x, and when we combine both of them, log of x into c. Okay. So I am substituting y by x for z, and at the same time I am also simplifying. Okay. So when I take the 1 by 2 to here, we will get log of root of 1 plus y by x whole square. I have taken this to RHS also. At the same time I am combining with this, so it becomes into x into c, right? I have jumped 2-3 steps here. So further when I simplify this, what do I get? X may get cancelled. So I will get log of c into root of x square plus y square. Okay. Which is same as y by x into tan inverse y by x. Okay. So we can take this as the function. Also, if you observe this equation, it is not explicit function, it is actually an implicit function. So we can leave it like this. Okay. We cannot write x as y or y as x. Okay. So this is an example of not exactly homogeneous style, but still homogeneous style. Okay. Come on, make a note of this. Next page also. Okay, so now we'll move to the next question. So again, this is one homogeneous, convertible to homogeneous form. So how do we do this? By using the same approach. But now that we have understood the process of conversion, so we can straight away hit it with the simple ideas. So there are two linear equations here. We want to solve both linear equations. So what we do is we directly take these coefficients. So h here, k here, 1 here. Here coefficients of y minus 2 comma 1, and here 5 comma minus 1, 1 comma 2, minus 2 comma 1. So you know this cross multiplication method. So what do we get? H by 2 minus 5, k by 10 plus 1, 1 by 1 plus 4. So it is going to give us h equal to minus 3 by 5 and k equal to 11 by 5. So what is our substitution? Our substitution is put small x equal to capital X plus h, which means minus 3 by 5, and small y equal to capital Y plus 11 by 5. Then our differential equation will directly get automatically converted into this form. So take only these two terms, okay. So x minus 2y by 2x plus y, okay. So if you have understood the whole process, you can speed up the process and attack only the required terms, okay. So this way we have actually done this process much faster, okay. Now what is the idea? We have to put y by x equal to z. So when we divide with x and put y by x equal to z, we will basically get here 1 minus 2z divided by 2 plus z, okay. What about the LHS? It is going to become z dash into x plus z, that should be equal to 1 minus 2z by 2 plus z, okay. This is the process. Now what is the next step? Of course we have to subtract z here, okay. So I'll put minus z here and also minus z here, okay. Then RHS will become 1 minus 2z minus 2z minus z square by 2 plus z, okay. So if I simplify this, I'll get 1 minus 4z minus z square by z plus 2, right. This is basically going to be z dash into x, which is same as dz by dx into x, okay. So now apply the variable separable form. So as you have seen, the conversion step is also not that tough, it is easy, but the main toughness starts the moment you start writing this equation, okay. So now let's separate the variables. So z plus 2 divided by 1 minus 4z minus z square into dz, okay, okay, equal to dx by x, okay. So till here it seems fine. Okay, now there is another important idea. Here if you notice, luckily the numerator has become the derivative of the denominator with just one difference of the constant, okay. So for example, if I just let us say multiply with minus sign and put the minus sign here, there is no confusion of sign, and d by dz of z square plus 4z minus 1 will become 2z plus 4, which is same as 2 into z plus 2, okay. By the way, my writing is little confusing, okay, because my writing was beautiful till I topped in my 10th school, but after that the moment I started preparing for IIT, again my writing became this, and my writing has been constant since then because of the speed and because of the time. I tried to speed up my writing and it became like this. So there used to be always a confusion between 2 and z. So what I did was, when I write 2, when I write z, both are of the same shape, okay. So if I write 2 and z, both will be of the same shape, but z will be having one cut and 2 will not have cut. That is the only difference, okay. So please understand that whenever I write z, I'll definitely cut it, so there is no confusion there, okay. So now here we'll supply 1 2 and we'll balance it, okay, and denominator remains same, which is z square plus 4z minus 1 and dz here. In the RHS we have minus dx by x, we can also put it in the LHS only just for the simplification purpose. So dx by x, this is equal to 0. We are going to integrate this, right. So it becomes 1 by 2 into log of z square plus 4z minus 1 plus log x equal to some constant which is log c, okay. So I can convert everything into log and equate both indexes. So then it becomes root of z square plus 4z minus 1. What did I do? I have taken this 1 by 2 to here, okay, into x is equal to c. This x is actually capital X, okay. Okay, so then what happens? Here it becomes root of y square plus 4xy minus x square, and x gets cancelled, equal to c, which is also same as y square plus 4xy minus x square is equal to c square. This is our solution. Now again we have to go for the reverse substitution. So what will be our final answer? Final answer needs to have small x and small y, okay. So we may have to put capital X equal to small x plus 3 by 5 and capital Y equal to small y minus 11 by 5, right? Okay. So then what do we get? Y minus 11 by 5 whole square plus 4 into x plus 3 by 5 into y minus 11 by 5 minus x plus 3 by 5 whole square is equal to constant, okay, right? That is what the expression was, correct. So this is our solution. Now let us look at the solution. What kind of solution is this? It is hyperbola, okay. So basically we will get the family of hyperbolas here, okay, having the asymptotes which are in the LHS. If we put this constant as 0, we will get the equations of the asymptotes, okay. So this way we can solve the problem. So here I have solved one problem by converting that into homogeneous form, and then I solved it till the end. So now you can look at the process and you can understand that the process is naturally long process, okay. Come on, make a note of this. This page also, okay. Now let us quickly solve another problem, okay. So this is a story problem. Every time I give at least one story problem on every method, okay. So here the problem is like this. The area of the figure bounded by a curve, area of the figure bounded, okay. So this is one simple phrase. So whenever we have big story like this, we have to cut that story into different phrases, okay. So this is one phrase, area of the figure. Area formed with what? X axis or y axis or some other curve, that is also given with x axis, okay. So that means it is basically integral of y dx. Area formed with x axis is y dx, area formed with y axis is x dy, okay. And then and two ordinates. So one of which is constant, other is variable. One is constant, the other is variable, okay. So that means even if you take a curve like this, let us say this is my x axis, this is one ordinate, this is one ordinate. Between these two ordinates we are talking about the area, but it is given that one ordinate is constant, the other is not. So I can take this as, let us say, a, and I can take this as variable, which is, let us say, x. We can take the other way also, it does not matter, okay. So let us say I take this as a, this as x. This must be equal to what is given? It is equal to the ratio, of course we have to find the ratio of cube of the variable ordinate, that means y cube, and what else? Variable abscissa, that means by x, okay. So basically we have done the mathematical modeling. Now our idea is to integrate this, right? Not so fast. Here we have taken x in the right side of the constant. If you had taken the x in the left side, it must have been a different story. So what is our mistake here? To put the modulus sign somewhere. So it must be 1 carrying 1 plus minus sign here, okay. So we have to deal with both the signs. So for that I will keep maintaining this sign while solving the problem also, okay. So now whatever is this sign, just ignore the sign and look at this. Is this in a standard form of any differential equation? Of course not. this is not in the standard form. So, to convert this into standard form, what is the idea? We have to differentiate it both sides and convert that into the standard form. Okay. So, to differentiate it, we generally take Newton-Leibniz theorem, which differentiates the integral. Okay. So, let me just solve for the plus sign only. Okay. So, you will explore the negative sign, that is better because we do not have so much time also. Okay. So, now when I differentiate this, I will get y of x into, this is the y of x into derivative of x, which is 1, minus y of a into derivative of a, which is 0. This must be equal to x into 3y square y dash minus y cube into derivative of x is 1 divided by x square. This is the quotient rule or division rule. So, what do we get here? We get y is equal to 3xy square into y dash minus y cube by x square. Now, luckily there is one y which is actually getting cancelled. So, we will get 1 equal to 3xy into y dash minus y square by x square. So, we have to get y dash here. So, I take x square here, y square also here, it becomes x square plus y square divided by, there is 3xy term here. So, 3xy here. Now, further it is in the homogeneous form. So, we have to go ahead with the integration directly. So, how do we do it? We put y equal to zx, right. So, that will give us x square plus x square into z square by 3 into xz. See, here I did not divide with x square, I directly substituted y equal to zx, it does not matter, it is the same thing. So, we will get 1 plus z square by 3z. Okay. So, let us solve this quickly. So, y dash equal to z dash into x plus z, we know this, and this must be equal to 1 plus z square by 3z. So, z dash into x will become 1 plus z square by 3z minus z, that will be 1 minus 2z square by 3z. Okay. So, now let us separate the variables. Here we get 3z by 1 minus 2z square into dz equal to dx by x. As I told, RHS is always dx by x, and here also luckily numerator became the derivative of the denominator. So, what is the derivative of this? It is minus 4z. So, we supply 1 minus 4 and balance it with 1 minus 4 and then integrate both sides. So, what do we get? We will get minus 3 by 4 here into log of 1 minus 2z square, and that is equal to log x plus log c. Okay. Now, just simplify this. So, we get 1 minus 2 into y by x whole square whole raised to minus 3 by 4 is equal to x into c. I have directly equated the logarithms, and then we can further simplify this as x square minus 2y square whole raised to minus 3 is equal to, so when we take the power 4 here, we will get c power 4 into x power 4, but there is also here one x raised to minus 6. Okay. Okay, so we can further simplify this or leave it also. Okay. So, let me just simplify it if it is possible. So, in the denominator there is x power minus 6, it comes in the numerator, so it becomes x square. So, we will basically get somewhat like this: x square is equal to c raised to 4 into x square minus 2y square whole cube. Instead of c raised to 4, you can also put one constant k here, it does not matter. Okay. So, this way we can solve this story problem also. So, when it comes to story problem, first we have to formulate the problem. This step is called as the formulating the problem or mathematical modeling. After that, solving becomes the same process. So, also if you have observed the homogeneous differential equations, the method is same throughout. Every time we go ahead with the same idea. Okay, so in the RHS we always get dx by x, always LHS has to be integrated, and that needs little bit of hard work. Okay. So, I hope you enjoyed the techniques and the discussions today. We'll meet again in the next lecture with the exact forms. Until then, have a great learning day. Learning shall never stop.